Today, I'm thrilled to have Somanath Nanda in the show. We give the Web3 Passport to Somnath. Somnath
Hi.
is also known as Baba. So, Baba, welcome to the show, the
Thank
Web3
you.
Passport. And the passport, yeah, goes to you today.
Thank
And
you.
as you're known as a philosopher of blockchain and decentralization, we look forward to know from you about your own journey into blockchain and decentralization, and also to know about your, obviously the journey and the use cases of blockchain and decentralization in a real world scenario.
Thank you, Charul, for having me here. And thanks for the Web3 passport. Now I have the license to talk about blockchain through you, probably, most of the times.
Yeah.
And I'm glad that you're associated with Hughes Young Mass in Ireland. And you're running pretty good right now. And keep up the pace. Yeah, like my journey started with blockchain, and good point was the philosophy of decentralization, because I feel it's a noble way of living life through community and through society, like having your people's opinion most of the times. Um, because through blockchain is the technology through which we can achieve decentralization,
Okay.
where everything is done through a consensus mechanism, through voting mechanism, where approval of most of the things are there, and it's recorded for future reading or future research purpose, where you
Right.
can use this information as a data for predicting or something. I'll talk a little about the AI part as well,
Okay.
like why AI is indeed required for blockchain sustainability, because you need to feed that intelligence to those participating nodes, participating, like in case of proof of stake, you can say stakers, validators. So they need to have that intelligence. So we need to feed that intelligence through those software programs. And
Okay.
this is why, like, imagine I bring in a proposal to you and you say, no, I don't like it. So there is some intelligence working for this result to have, okay, I don't like it, I don't want to vote for it. So that intelligence need to be fed similarly to those nodes who are part of this blockchain network.
That's
And
very
this is why
complex.
where we are heading now.
Okay.
So like there are a lot of scientists, researchers working to bring in blockchain and AI together.
Interesting.
Yeah.
So, Baba, that was a fantastic explanation of how the blockchain works and how the decentralization. Now, yeah, so for the audience, I have my laptop here with me because we have so much to cover with Baba today in this conversation. We have to deep dive into blockchain, decentralization, and consensus mechanisms and algorithms in a while, gradually with Baba. So, Baba, what is the real life in use case of blockchain currently in 2023?
Of like
Can we say?
you can associate every business with blockchain. Like that's how I look at it, because there are, like, if you look at a very small part of it, your day-to-day online shopping system, that can be on blockchain. Your supply chain, like for any
Yeah.
order, there is a massive network of supply chain and logistics running. You can use blockchain there. Even for hiring system that we have at the moment, you can have blockchain there.
Okay.
For your hotel bookings, for your flight bookings, everything can be transformed into blockchain
Right.
technology. Like in short, you can say, uh, okay, I will try to give you a tool to decide can I use blockchain here or not. So
Yeah.
something like, imagine, is there a business where data is involved? If answer is yes, yes, there is a usage of ledger.
Right.
So if I was storing the data in database, now let's take it to the ledger. So okay, one tick of blockchain. Let's look at this. Do I need intelligence on those information that I'm storing? If yes, like you are doing some data analysis, running some machine learning algorithm on your past data or something, can be done? Yes. Okay, blockchain, another take. Now let's look at the mechanism, how they function. For any database updates, we rely on the application, we rely on the person or the guy who is running the database. Basically, let's say there is a company XYZ who is maintaining my database, then they have all the rights on my database, right? Now, if
Right.
I push that thing onto the ledger,
Yeah.
it's a truth-based mechanism because every participants are involved to through a consensus mechanism to validate that information. Okay, then I need that. Like every business need that. Like why
Yeah.
to run on a trust but on the truth? So yes, tick. So if a business takes all of them, feel that okay, they should transform to blockchain technology.
Right. It can transform to blockchain technology, but has there been any industry that's been successful uh, by now,
Oh
or
yeah, like
there are? Okay,
you
so
are many. If you look at, I was recently reading an article. Not recently, probably it's been a year now. Um, I was having my holiday and I read
yeah.
about this jewelry company. They wanted to make NFTs of their uh, jewelry, and but they will be delivered later, like you do in a normal business where you say a future thing and you give a bond kind of like written on a paper and you have a value to that particular piece of paper.
Okay.
Now the same thing came up as an NFT that we're gonna make, let's say, 400 jewelry of this particular size of this category. I don't know much about that, but I'm just giving an example. So they could do it. If you look at all the big brands like
Yeah.
Nike, Pepsi, and if you look at all the
Maybe fashion
beverages
brands.
brand,
Yeah.
fashion brands, car brands, like the F1 cars, they are
Okay.
also transforming their business to blockchain technology
Okay.
because they also want a footprint in future. Look at the business.
Yeah.
It was something like, okay, let me give you an example of shoes. So when you go to buy a shoe, you look at the, like you go for the rack and in the rack you see one size, like 10 size, 9
Yeah.
size, 8
Yeah.
size, 6 size. Okay, they are given in one, like in different designs, or maybe in a similar design of one pair. But can you mix match? No. So that experience was never there. And
No.
so now they have transformed that shopping experience, like where you go into metaverse,
Yeah.
you choose your own size, you choose your own design. So shopping is
Yeah.
now provided as an experience rather than a service what it was earlier. If you look at it, there was a shop, you go there.
Yeah.
Now you can go to anywhere, and for an identity, you just need few NFTs as a token. Earlier, it was like a card, and those card you go used to swipe in, let's say Nike store, in Adidas store, and Puma store. But now you just have one card, one identity, and you just go travel wherever you want to do in
Right.
metaverse.
And now, as you have touched upon NFTs, right, we would like to have a more deeper conversation with you on NFT because there is one opinion, one sector of people have an opinion that NFTs are worthless. There is no use case
There are a lot
on
of
it.
use. Okay,
Right.
when you
Yeah.
say, um, okay, when we say useless, we
Yeah.
consider in terms of value. But if you look at it, let's talk about it and then figure out what do you feel is there a
Yeah.
value or not. Let's talk about it.
Right.
Let's take an example of Web3 Passport. What we are
Okay.
doing.
Yeah.
So let's take it as a product and let's build it here.
Lovely.
So if you look at it, uh, you living in Ireland, if you want to travel into Schengen countries, you need to go to one of the embassies and you need to get a Schengen visa for that to travel into those countries. Okay, perfect. There's a regulation, happy to follow it. But when we do that, you need to carry your passport. You need to print it 100 times or 10 times during your lifetime, how many years you want to hold it. You need to have certain amount of pages for those stamping. So we talk about a lot of energy consumption, printing and all, and what are we doing? Can we transform them digitally? Yes, Web3 Passport is the solution. Then comes, I'm just giving you a small use case.
We want to know from you because your understanding is it's intense. That's why you're called a philosopher
No.
of blockchain and decentralization
Thank
because
you.
the way you explain these concepts are so easily understandable by anyone out
Oh,
there.
because we are a social animal, and the way
yeah.
we run the society or we live the society, that needs to reflect in your technology. Because it's
Definitely.
meant to help you.
Yeah.
So if you look at the, going back to the same example
Yeah.
of having number of stampings, let's create a dynamic NFT, put a list, and in that list we can keep all those countries that you are traveling
Yeah.
with a date. That's it. It's just an information, but why do we need papers? Can we store it digitally? Yes, let's put it in a ledger, create an NFT, give it to the people. Let that network be run on a public platform
Right.
with high privacy by using, like, we have ZK rollup now. We can use that. Like, there are several other options as well, but I'm just keeping it short. Like, what are the different aspects would be there for the product, and what
Okay.
can we use to build this entire Web3 passport? On top of it, NFTs can be used to identify, and with soul, like, okay, we identify human beings because they have souls, so the soul bound animals. So soul bound token, so soul bound NFT. Make it like that, make it dynamic, keep on adding those information time to time.
Yeah.
And if we need to keep it, okay, we have lost track of even mankind because we don't have right history. Let's start it from now so that future generation will have a digital history to read about us.
Yeah.
So through these NFTs, we are storing a lot of information. How can you say it has no value? Okay, when you say look at the pricing of it, like the way it happens on marketplaces. I will talk a little about marketplace, why we
Okay.
call everything as a marketplace. Like, we used to have shops, we used to have business, we used to use those words. Now we are moving out of shop business to everything
Marketplace. Yeah.
marketplace. Why a marketplace? Because
Why?
it's a place where there is a value exchange. That's it.
Okay.
We do not have a standard anymore that you need money to do this,
Right.
because there are
Right.
several tokens where through which we are
Yeah.
exchanging values, and NFT is one type of those tokens
True.
which is used for parsing those values or storing those values. How can you say it is useless? I don't see like that,
True.
and I see they have a massive future. Like Web3
Right.
Passport, yes,
Yeah.
100%.
Okay.
100%, it's coming up.
Now let's go back to blockchain. Mentor or in an ABC format to somebody who don't know what blockchain is, and just to convince the people who are not technically equipped with these terminologies. How would you explain blockchain to somebody?
Okay, it's
Yeah.
technology. I will, I will first say that we learned about it from Bitcoin. Even Bitcoin had a social philosophy behind it, and the idea behind Bitcoin was decentralized payment system. So it was made uh, just as a financial
Store of
instrument
value.
or financial equipment, you can say.
Okay.
And slowly, like, that idea of decentralizing one ecosystem has propagated to decentralize everything. That's why I believe that on that idea, like, profoundly. Now, if you compare that thing with social norms, the way we run or we live in the society, there are several aspects to it. For example, finance. For example, logistics. So let's take an example of this basic finance. Earlier social
Yeah.
systems,
Yeah.
it was something like I exchange this something which I have created, and against this I used to get something back, and they were quite need based. Everything has changed into a proper mechanism of with monetary system where money is used for any exchange. So whatever exchange you do, there is money as a like subtask associated with it. So that's where you are exchanging money with some asset, right?
Yeah.
So this is the value of that
Yeah.
asset that you are exchanging through money.
Right.
Now, with that being there in society, if I have to build something in technology, then I need this blockchain technology. So that's the
Okay.
decentralized way of living, I
Okay.
would say, because that's how people used to live. And they try to build a system where these information or data can be stored on blockchain as a technology,
Yeah.
and there will be a value associated with it. When I
Right.
say value, um, in an account,
Yeah.
you keep the details of Bob took €5 from Alice, then that €5 is the data that you are storing, and information is Bob took.
Yeah.
Now, if Alice is taking or giving back anything to somebody else if there is there, then we do some certain amount of maths to have an account. And the same thing is stored there, which is public and transparent. There are challenges to these systems as well.
Yeah, and what are they at the moment?
If you look at this system, now everybody needs to have this information. If everybody has to need to have the information, then everybody needs to talk. Like through digital communication,
Right.
you are paying for it.
Yeah.
So you need electricity. So that makes the information passing slow. This is why there are several other options like for those scalability. Security is a challenge as well. Why?
Okay.
Because so many nodes or so many involved parties have those information, and if
Right.
one is twigged, then there is a question to the security.
Okay.
And to avoid that, there are certain mechanisms, but
Right.
still we have so many hacks happening, and
Okay.
the, it is a continuous process.
Yeah.
It will be there, like hacks will be there.
Okay.
But yes, this is still a challenge.
Yeah.
I don't see any other problem to it. Yeah,
Right.
in consortium systems like where like only few participants are involved, like there are new projects coming up like every day,
Right.
and
Every
with every
day it's
day new projects
massive.
coming
So
up,
fast paced.
like with that,
Yeah.
there is a challenge that there are few projects run by only few participants. When you have very less number of participants, you cannot trust them, and you cannot trust that product, you cannot trust that blockchain if it's a new one. So that's a challenge. So when you are, for example, if you are building a decentralized application and you
Yeah.
need to find a blockchain, I would say look at some blockchain which is run by maximum number of node operators or
Right.
validators.
And
That's the key thing.
how would that's interesting to hear, but how would somebody find that? What's the research process looks like? And also is
Yeah.
blockchain only for like bigger corporations or or small startups or middle-sized companies can also adopt to that? Is there a kind of a segment to the companies
Very
or
valid question.
organizations or public organizations who can only adopt or who cannot adopt to blockchain?
I think going forward, it will be more like a service.
It's a
Uh,
service.
it will
Okay,
be like
it
a
will be.
service. Like
Okay.
now, if you look at this, there are like every day, like if I have to launch a blockchain, it's just few lines of code that I need to run,
Okay.
and I'll start a blockchain. And
Right.
let's say I want to create some network like Bitcoin or some network like Ethereum,
Yeah.
I can. They're open source code, and I can just take them, make some few changes on my own, and I can start it.
All right.
And I need to open source it, and so many people need to adapt it and do it. But the idea behind this is, why do we need so many blockchains?
Why do we need them?
Yeah.
Yeah.
So can we manage with only few? That is like
Yeah.
a few profound ones.
Yeah. Would
If
you?
yes,
Yes.
then we need to have a separate layer on top, which can provide service on these chains. This is why I feel like in future, like not in future, like it'll be in like in very recent years, it will happen. There will be few trusted blockchain.
Okay.
Like if you look at the current scenario, there are several database companies, but are all of them successful? No. Like now, keep storing data created as a service on multiple cloud platforms.
Yeah.
Similarly, it will be something like blockchain, and there will be a service layer. Through service, people will be interacting. They don't need to know how many networks they are spawning in the uh, background and how
Yeah.
they're running it. So that will create that easiness for every common people to adapt it.
Right.
Now it is looking tough because people think, oh, it's a lot of code, it's a lot of software programs. If you go back 20 years back, storing information was a tough challenge. And when I say tough challenge, there was no database. People used to create files, and people used to store data in those files. And slowly, we started. Oh, we are able to store in file. Let's go to database. Now, from the database, we are creating so many different other
Ledgers.
services
Yeah.
on top of it for easiness. How many
Right.
of the like, if you look at the mass engineers, they don't want to learn how it is storing. Okay, I'm storing. It's a reliable thing now. It's a database. I rely
Yeah.
on the database. Similarly, people will start relying. It's just a blockchain. I have a
Okay.
service to access it. I have a service to read data from it.
Yeah.
I need to give some value, like some like exchange of tokens,
Yeah.
and I'll be able to read the information and run my business. It will be like that, and like very
Smooth transition.
yeah,
Yeah.
it's already there. There are so many blockchain service companies
Yeah.
sprouting everywhere.
Every, can you name some really the blockchain companies that you're or projects that you're very confident on? The top
Uh,
four or
I like
five.
Chainlink.
Okay, listening to your use cases on
Thank you.
Chainlink, that was the first time my concepts got really clear on where
Thank you.
Chainlink as a oracle
Yes.
is useful.
I'll take an example of one of those consensus algorithm,
Perfect.
and I'll give you a like real scenario of how these communication work, and I won't talk a lot in terms of technology. I'll use few words from technology and I'll try to relate them. Like
To the
if
real
a
life.
human being, like
Yeah.
I won't use computer. I will say the program is your intelligence,
Yeah.
and the computer is a human being. So
Okay.
let's talk in that way, so
That
every
was
human can understand.
perfect.
So, yeah, Chainlink. Top four, I would say, yeah, I like Bitcoin, Ethereum. My decent choice of this is now Polygon because I'm working on something. I'm trying to understand a lot about those layer 2 solutions and how they're implementing ZK rollups. I will talk a little about ZK rollup,
Roll-ups, definitely.
how that's gonna work
Yeah.
uh, in these ecosystems,
Okay.
and yeah, Chainlink. I have done few research about. I was reading about Arbitrum recently, why they are so fast. Uh, so yeah, we will talk about it. And I would have been sitting now in some bar or baking sun outside having a beer.
Yeah.
Uh, but it's fine that I'm here enjoying these
Yeah.
talks with you.
Yeah. Yeah.
And most importantly, if you if you compare the older way of education system and the current education system, there is not something new coming out of it.
There's
It's
no
like
something new coming out.
yeah, so like same thing is getting propagated to generation from generation. The information you keep on feeding, slowly the intelligence develops.
Yeah.
It's nothing that you can feed. It's something abstract, I
Yeah.
would say. Yes, mankind is trying to achieve that, and if you keep on repeating the same information, imagine will the system develop more intelligence? No.
No, no, no.
So then, so the more experience you have, like the different perspectives you try to see. This is why GPT or these AI, like large language models, they need to be tested on different type of perspectives, different type of people, different type of societies, like existing in the whole world.
Yeah.
Then we can say probably this happened. Yeah, we are never 100%. We'll be always less by some percentage. But yeah, that mass adoption is needed. Once that happens, even that will bring revolution for blockchain area,
Yeah.
because more number of people will participate.
True.
And that will lead to the higher amount of decentralization. And
Very good point, mate.
like that needs to develop over the time.
Yeah.
And the way I look at it is, okay, we were living a way where organizations were run by one person or maybe by three people, four people, and they were, for example, any traditional company you look at it, they are all run through few group of people, like maybe five or six, like with some C-suite members, right? But if you look at the current way of running the organizations on blockchain, they are run by the participants. So everybody has an equal right to talk about it.
Right, right.
We never lived that.
Right, we
now,
never.
Now we have started living it.
Yes.
So,
Yeah. Equal
which
participation.
is good.
Community driven.
Yes.
Absolutely.
Which is good.
Yeah.
And slowly people will start adapting it. Like even when I talk to my father in these terms now, it becomes quite difficult to make him understand that
Yeah.
okay, systems are changing.
True.
Because most of his life he has lived in one type of thing. And if you look at me, I lived that, and slowly I have transitioned to this when I learned about it and I started talking about it. and it changed my perspective for most of the things. Even for a very small thing, I'm not willing to decide immediately, but I am trying to ask other involved members as well. So it's just the way you live. So you need to live with that philosophy that okay, you need to consult or you need to validate some information with others and then propagate it. So that's how
Right.
we can achieve decentralization, and slowly technology will adapt and everywhere it will happen.
Right. Very nice.
That's how I
Yeah.
look at it
Right.
at the moment. And talking about the security of the information, which you asked earlier,
Yeah. How are we
let's
gonna make it
yes,
secure?
let's talk about privacy first and then
Yeah.
security.
Right. Like, can we say that Luna was one of the example of security being compromised?
Yes, in
Yeah.
a way you can say that,
Yeah.
because a hack is always a question on security,
Security. Yeah.
right?
Indirectly.
And something is not secured because, in the first place, it was not made private. If it is private information, so whatever leaks, it is private, no one can read. So first maintain the privacy, then like it's a step towards the security. It's a step towards achieving security. So how do you maintain privacy? Privacy of what? Let's first understand privacy of what? Privacy of a data. So when I say data, you extract information from a data, and what is important? The information. So let me give you an example. Um, I talked about the scalability, like we have to pass information from each other.
Right.
So imagine I have to tell someone in
Yeah.
a community, you are a
Yeah.
human being, I'm a human being, and there are, let's say, 5 other human beings, imagine, and
Yeah.
we are talking about something.
Okay.
And there are 20 human beings, like 20 participants of this trustee or this community, are not right there at this point of time. They are like doing something at their own pace, but they need to know because they're
Part of
participants of
Yeah.
the ecosystem. You need to pass the information.
Right.
How? You need some technology, digital devices, quick, super, nice. Let's go to the next step, how it happens. Now, with this, I will explain Byzantine fault tolerance.
Okay.
Let's not talk what is Byzantine fault tolerance. Let's just understand that this is Byzantine fault tolerance at this point of time.
Okay.
And I'm going to explain with this example in
Lovely.
society.
Yeah.
So let's say you say, I have to give, so Baba has to give €5 to Charul.
Yep.
And all the 25 participants has to approve it. Now, Baba, name, amount, a value, you as a receiver, your name is important. And there is a check, a normal system. Okay, am I 18 years old? Am I born beyond this? Whatever. Now, this information has to be verified. That okay, is this a real human being? Is there an amount and all these? So, what needs to be checked here? Does Baba have that amount in the account? But there needs to be a software, there needs to be an intelligence which is reading, okay, who has the knowledge that, okay, Baba has €25 or $25 in his account and he is eligible to give $5.
Right.
So instead of asking, like
Yeah.
instead of reading how much I have that, if I ask the system, like ask your intelligence now,
Yeah.
do I need to tell somebody Baba has $25 in his account? No. If I can say others,
Yeah.
Baba has enough amount
Okay.
to pay.
To pay
With
that.
this, I'm not leaking the information of $25 to anybody.
Right.
That's
Right.
privacy.
That-
How my brain is working? My brain just took $25, did some mathematics that, okay, $5 is less than $25.
That's enough.
And that's enough to make this payment happen. I'm just telling the world, Baba has enough amount to make this transaction.
Lovely.
I'm not telling anybody that Baba has $25 and they will decide. Now they have to run the
Right.
mathematics.
Right.
So when everybody
right.
runs the mathematics, it's a processing. I avoided that processing and I rolled it up to another machine who is doing it. This is zero knowledge. Without knowing the data, you are rolling up that complete process to a certain layer, like the below layer will do this and propagate the information. He's eligible to do this.
Right. And what's
I
that
Yeah.
layer? What's that layer? Is it this was the example that you have given on Byzantine fault tolerance?
Yes.
Yeah.
So in this, Byzantine for fault tolerance is there when this is validated by two-third group of the people. So now I will give you a similar example in this. Like I will take this example, but I will take you in a different direction to achieve
Okay.
Byzantine fault tolerance of that information.
Right. Perfect.
Now,
Let's go for it.
now some device, some machine, some computer ran some program and told me that okay, Baba is eligible. Now I got this information and I'm gonna tell everybody in the ecosystem. We had 25 members. I'm gonna tell all the 24 members, hey, Baba is eligible, Baba is eligible. Some other guy, like in the same ecosystem, out of those 25, they found out they tried to give you a wrong information. They tried to say, Baba is not eligible. So this is a hack, let's say. So that
Okay.
machine is rigged.
Okay.
That human being is rigged. And that human being is propagating a wrong information to the network, to all the 24 people.
Yeah.
Even I am getting that information. I have given an information and I'm also receiving an information to validate. So all 24 participants of the network will also give me the information. So it's everybody talking to everybody. That's why it's peer-to-peer and decentralized. See, easy peasy.
Right. Easy.
You
peasy.
understood peer-to-peer, you understood decentralized.
Decentralization.
Now I'll go
Lovely.
one step
Yeah,
further.
yeah, okay.
So everybody is propagating information to everybody. So 1 is to 24, and
Okay.
everyone has that 1 is to 24 propagation
Okay.
of messages.
Right.
Now, the machines, like I got the information, so I got 24 AS, 1 no. Same with my other peer, 24 AS, 1 no. 24 AS, 1 no. Now, I will check, do I have two-thirds of the vote to approve this? Yes, two-thirds of the vote is saying, like more than two-thirds is saying yes. So it's approved information. Now everybody will have this information. Baba is ready to make the transaction.
Okay.
So someone will do the transaction now in this machine, like in this ecosystem. So there is a several, election mechanism there. This is why. So it's like normal voting process.
Okay.
Like they vote, okay, now this need to do the work.
Right.
I need to do the work. This guy need to do the work. When I say work, it's some kind of task of
Yeah.
passing information
Okay.
or doing something. When I say doing something, we'll come later to smart contracts and how they can be automated and how Chainlink plays a bigger role there. We'll talk
Okay.
about it.
Right.
But before going there, let's
Tick box there.
end this.
Yeah.
Third parties are approving this, that okay, this information is right.
Yeah.
And there you achieve Byzantine fault tolerance, practical Byzantine fault tolerance.
Right.
So it is basically a voting mechanism where two-thirds of the participants approve the whole transaction.
Okay.
That's it.
Right. Can I also ask you, maybe it's going to be a stupid question,
No,
but there are
nothing is
like
stupid.
24 people out there. So one person is sending the message to 24 and everybody has that right. So how is that data stored? Is it stored somewhere? Because it's going to accumulate too much. Like now I'm thinking it from the actual database point of view. The databases that we are using
You don't
right
need
now.
to store this information
You
for
don't.
long. It is just for
Okay.
that amount of time where you need to
Okay.
process.
All right.
So there are several solutions to it. Okay, thank you for asking this
Because
question because I
24
will
into
go
24,
Yeah,
yeah, it
good
multiplies
question.
into.
So I
yeah.
will go one step deeper now, like in
Okay.
terms of technology
Yeah.
and relating to human being. You are doing one transaction, so I'm paying €5. Do I remember this information? Ever? Like I paid
well-
€5. I just keep it for accounting. If I come back, I
Yeah.
can see it.
Yeah.
Do I need to remember it forever? Do I need to
No.
store it in my brain?
No.
So do I need
Not
a storage
really.
device for that? No.
No.
The end result, the account information, that is stored.
Okay.
So this particular information is like the way you are quickly doing it and flushing it from your brain.
Okay.
So there is something like that. It's called mempool where the transaction goes and it happens
Gotcha.
in that way. I don't want to go there. What happens inside mempool? Let's keep it for future.
Later.
If you want to compare with Web2 world, I know there are so many Web2 watchers as well who wants to transform from Web2 to Web3. If you want to compare there, it's like a cache. It's not a storage and database. It's just a cache which keeps on flushing. Just compare with that for the moment. We will talk later about mempool and how it works, what happens with mempool.
So, Baba, we were talking about Byzantine fault tolerance algorithm, and that's where one node sends the message to 24 nodes. Just for an example, we took that example. So 1 to 24 communication style, and every node has
The same
same
information,
information,
and they
same
gives a
authority,
message with a validation result.
and same rights. So how can we make this more private? Is it possible to reduce those
Yeah,
nodes from 24?
you can do it like let's say you don't want to tell this or pass this information to 24 of them, and you want to
Yeah.
just let 10 of them to know about it. So
And does it bring, and then it's just merely, the question is to how can we bring more privacy?
yeah,
Why do
so
we,
instead of telling all the 24 participants in this conversation in society, let's say there are
yeah,
24, let's make it A to Z, and so we can use each characters as the
yeah,
human being's name.
okay,
So let's say A is trying to send a message to B, and B at the same time is trying to send a message to K. So
okay,
the same information is going because they are just doing their job. So
right,
let's squeeze it that, okay, for one particular transaction, we will keep only 10 nodes involved.
okay,
You can do that. And how will you do that? So you need to, instead of sending that information to 20, you need to send it to 10. Now, how is that 10 coming from? We'll come to that in a while.
okay,
But now I need to send those information to 10 people. And
yeah,
those 10 people will give me the validation
okay,
to a certain percentage, like two-third of this, or you can set your own percentage. Okay, if I get 67% or if I get 51%, I'm happy with this. So with that, you can process that information within those 10 participating nodes instead of all the 24.
okay,
And how are you going to choose those 10?
yeah, how are
There
we going to
comes
do it?
another challenge of choosing those 10.
Right,
So, or who are those 10?
okay,
So this is called federation. So instead of 24 all making it public, you kept the information within the federation of 10. Now, how those 10 are decided? There is a particular process of choosing them,
okay,
and there are several consensus mechanism to choose those 10 number of nodes based on trust, based on their past experience, based on their reputation and all. Yeah, accordingly you choose those 10. This is why most of the hyperledger technologies, I'll talk later, for the time being let's keep it short. Like hyperledger technologies, they prefer to have a federated Byzantine fault tolerance,
okay,
because here the information is not with everybody, it's with those trusted people. So federation keeps the information trusted.
well, and
Those, yeah.
yeah, another question is, so when it was 1 to 24, wasn't it that fully, how can we say that? How can we be sure that that wasn't trusted? The information back then wasn't trusted.
Okay, we tried to keep
Yeah.
the like we used to roll up there where we just didn't propagate the data, we propagated the information, yes or no, or something like valid or invalid, like allowed, not allowed kind of information we just sent. And that was processed by all the 24, which is if you look at it holistically,
Yeah.
all 24 human beings are using their energy to process this. And so in technology, all the 24 computers or 24 devices are consuming some power to do it. And so there is a processing usage. There is a network lag because processing is there.
Yeah.
24 people needs to give you result back. Now only 10 has to give you the result back.
Right.
It will be faster.
Right.
So you achieved scalability. Wow. So
Okay.
that's cool. But there is a little bit of processing with respect to practical required in federated, because you need to find those 10.
Right.
So
Okay.
there is a process for this. And this is why it's federated. So we
Right.
keep
Okay.
that within the federation.
Interesting. So now, can they? So the Byzantine fault tolerance and federated fault tolerance, they are utilized
They,
together.
they are Byzantine fault tolerance.
Okay.
One is practical, one is federated.
Okay.
The difference is in practical, you give the message to everybody.
Okay.
In federated, you keep it within those trusted parties, within those chosen nodes who are meant to make this thing happen or make this transaction happen.
Right.
So that's the difference, I would say.
Right.
Here, the information go to all. Here, to the chosen one, the
Right.
selected.
Would you also explain a real-time use case at the moment of
Uh,
these?
yes, Hyperledger Sawtooth. Yeah, they
Okay.
use federation, and
Okay.
if you look at it, this idea came from our like the way we live in the society.
Tell us more about it.
Uh,
Yeah.
yes, so it's like you might have heard about this federation, that federation.
Yeah.
So
In
when
the
we
general
say
governance terms
yes,
like
so
federation, our
because they
federation.
want to have trusted people in the community who are
Yeah.
running a particular part of the business, and they are meant only for that business, and
Right.
that there the federation comes in, and that's what we have brought into technology. That okay, in let's say it is something like okay, if this particular geographical location has a federation, there is another geographical location where there is a federation. So they are running the federation because they are the only trusted parties in that geolocation. So with those being there, you keep the information private within those federation. Yes, federation can talk to federation with some kind of agreements.
Okay.
Like this geographical federation can talk to this geographical federation.
Right.
Like in terms of technology, there needs to be interoperable. This is why there are
Interoperability.
so many talk going on the interoperability, because there are several networks who are keeping their information within their network. I'm not
Okay.
saying they're federation, but if you look at from 40,000 feet, then this network, this network, this network, this network, information is private in that network itself. If they want to communicate, there is nothing at the moment. There are options, but I'm saying there needs the question of interoperability of that information between
Yeah.
different networks. We'll
Uh,
talk about it later.
right. Okay. Okay.
It's something like a group of people are interested in books. So there is a blockchain network. A group of people are interested in music. There is a different blockchain product or network run by some like enthusiast, you can say. Because technology is in people's reach now. Everybody wants to learn it, and they
Yeah.
are launching their own.
Right.
But is it required or not? We are not yet sure. And
Yeah.
I think there can be layers between these networks.
Okay.
When I say layers, what I mean to say layers in terms of design, not in terms of network layers. So design in the sense there will be one layer who will be serving all these, and they will be selecting few nodes to do something. So it's a kind of more number of election process through a mechanism of doing something. So,
Okay.
for example, 10 people will choose one leader, and here 10 people will choose one leader. These leaders are like, you know, how do I say? These leaders are the representative of those many number of people, and those leaders can choose their representative who will be running the entire network or something like that. And so, in this kind of mechanism, you might have heard about delegated proof of stake, uh, where the delegation happens. So delegation
Okay.
of what? Delegation of election mechanism. So
Okay.
I'm using Byzantine fault tolerance
Yeah.
in every layer
Okay.
for sending the messages, because Byzantine fault tolerance says send the message to everybody, get everybody's message,
Right.
and check what are they saying,
Yeah.
and check how many percentage of people are agreeing
Right.
to that mechanism or whatever action you are doing.
Right.
So, with that being said, it is there in every layer, because everywhere you are, like in every layer of election mechanism, you are choosing through this process.
Okay.
It is there,
It is there.
but the delegation of the things are going layer by layer.
Okay.
So,
Okay.
yeah,
Interesting. Makes sense.
and
Yeah.
there is a concept like which Chainlink follows, like with just this talk I've found that I should talk about it right now.
Right.
It will make more sense. Uh, they they have off-chain reporting. So in off-chain reporting, what happens? These social activities that is going in our real world. These information needs to be there on blockchain. It should not be only financial information or any thing that can be digitized. There are so many things which are not yet digitized, and those information needs to be there. For example, weather information is very vital for insurance industry, for several other industry who are running their beverages or food, because based on the weather, there are
Different
like the
variations
yes,
or
in terms of the food
yeah.
choices,
Yeah.
the like hotels or other businesses, travel industry, like everybody plans according to that.
Yeah.
So it's a very vital information,
Definitely
and
weather.
that needs to be. So that information needs to
Needs
come
to be
from
real
more
time.
number of decentralized node operators,
Right.
and so that that off-chain information is there and on-chain,
Yeah.
and we are able to run the business on-chain.
Okay.
And Chainlink plays a bigger role there to maintain the consensus of the data. So when I say consensus of the data, it's like, okay, 20 degrees Celsius is approved information
Okay.
by the participants. And who is sending me the information? Okay, I got the information from a leader node. And who is that leader node? That guy is chosen by some other nodes through some consensus mechanism and election process.
Wow.
So this is how they are
Wow.
maintaining
Wow.
uh,
Yeah.
the validity of or the correctness of the information, and it is an approved information by so many players or so many participants in that off-chain world who are running the Chainlink algorithm to give that information.
Okay.
So yeah.
And we do have the real time use cases of how Chainlink is being used currently. We
Yes.
Yeah. We would like to know more about all these use cases where
Yeah. For example,
Chainlink
you
is
are growing
helping.
a tree,
Yeah.
and you need to put that information on blockchain. How will you do that? So there needs to be a human being who comes every day, measure it,
Right.
put the information, and that
Yeah.
information is validated and
Yeah.
brought into blockchain, like
Okay.
it on chain for doing something.
Yeah.
And why is it needed? So
Yeah.
okay, there is some money spent. So if you look at the way the carbon credit calculation happens. So for some amount of carbon dioxide being emitted, there is a plant being planted. So for that, there needs to be, okay, this much amount is gone for planting. Is it really being used or not? Who is going to validate? Okay, donation process is happening on blockchain, but the tree growing process, how can we bring that information? For that, that's off-chain information that needs to come there. So there are node operators working for bringing this
Okay.
like information on blockchain. Second comes parametric insurance industry. It's a bigger one, and they are mostly based on the weather information, rain information, the wind, pressure, and so many weather attributes you can say. So those information needs to be tracked because accordingly the agriculture business is affected.
Okay.
Accordingly, warehouse gets to know the information and they run their business, and insurance companies who are insuring the farmers because it's a thing with the weather and they could not handle it, and so they need to be insured accordingly. So these informations are vital for such
And
insurance
yeah.
industry.
Right.
Apart from this, there are market data, for example, price feed information from decentralized exchanges. If you compare there is a concept of circuit breaker. I won't go deep now, but I would say something like, based on the market, you want to do some action. So you need to have some system where you need to get that information constantly to do that action. So how will you get that information, and who is going to provide? So Chainlink is playing the massive role
Okay.
to handle those financial fluctuations on decentralized platforms.
Okay.
So for all the DeFi applications to be secure,
Yeah.
you need to have these mechanisms, and
Right.
they can only be achieved when you have that information. So Chainlink is providing that price feed information. And it's not only for price feed. I'm just giving an example. You can integrate any API for that.
Okay.
But I'm saying yes, like it will be more easy in future. Like you just don't need to write so many of the code because it will be something like, okay, you just plug this and things start working. And this Chainlink as a decentralized Oracle platform
Yeah,
is
we have
playing the big
spoken about the Byzantine practical consensus algorithm. We also touched based on a federation,
yeah, federated Byzantine
Federated?
fault tolerance.
a federated algorithm. Now, I have questions to you about the other consensus algorithm. I've heard of proof of work and proof of stake as well. So, would you share some light on those? Maybe let's start from proof of work.
Yeah, so uh, let me try to put it the way they're named. Proof of work, like you have to prove that you're working.
Yeah.
Proof of stake, you need to prove that you have stake in the system or stake in the community or within those people or whatever ecosystem you are in. For the decentralized voting activities and getting rewarded, I will talk about it. But yes, that's the essence of proof of work and proof of stake. Let's understand it
Okay.
like in a real world example, and then we will try to put the same in terms of technology, how they are being used for blockchain.
Okay.
And I will try to cover a little bit of security there. Please remind me if I skip anything. Please. Let's take an example of like time and work mathematics, where like if somebody does this amount of work in less amount of time, this is why they are inversely proportional, time and work. So if you do more amount of work in less amount of time, you are considered efficient,
Yeah.
right? That's how time
Yeah.
works. And in terms of that, let's say you have built like a society or a community of, let's say, 100 people, and they are elected based on their efficiency. The amount of work they are doing in a particular amount of time will define their efficiency, and they will be chosen uh, as a leader for a certain amount of time to do a certain amount of or a certain type of task. So, for example, I have to put a street light. So that's my task. And who I'm going to choose out of these 100 people. So you put the proposal there, 100 people participate, and you found the efficient one, and that efficient one is decided to do the job of putting the thing.
Okay.
Similarly, let's take an example in a technology world, like the way Bitcoin works. There are several number of computers who are trying to do some kind of work in an amount of time, and based on that, their efficiency is calculated, and one of those computers are chosen to do a transaction. Simple. Now, if you look at the particular amount of work, so in in one statement, it was very easy to understand, but there is a lot of process going on, and let's
Yeah.
go step by step.
Okay.
The work. So computers are doing work.
Yeah.
What work are they doing? So they are
Processing.
given some information, and they are using the information, giving me some kind of result. So what is that job they're doing? They are doing basically, okay, let me think of an example. Like they are doing hashing of the information.
Okay.
So if you, okay, let's understand what is hashing a little bit, and then I'll come back to this. Hashing is something like it's a box.
Yeah.
You give something, and you get a fixed length of output.
Right. Yeah.
And it's going to be different if a different information comes in.
Right.
So the same output cannot be generated from different inputs.
Okay.
One input will always have that as an output.
Okay.
And it's a fixed length size, and it's going to be different if a different input comes in. So let's understand hashing that way. So these computers are always busy doing the same thing to a particular problem. So, but we said they are doing some work. So work has a particular goal.
Yeah.
So why are they doing it? What is the goal? The goal is they are given a problem that, okay, if you give me this within 2 minutes, you are the winner, like you do it in a class. So you give an assignment, and
Yeah.
if somebody does it first, you say, oh, you do it. So first and right.
Yeah.
So someone can come first, but they may not be right.
Yeah, the more.
So someone has to be, and someone is coming after this first guy, but they are right. So that's the first right candidate.
Okay.
Right. So this is how in the proof of work
Work. Consensus.
concepts,
Yeah.
we use the similar kind of thing where they do hashing as the job, and the goal is to match with something. And the faster they do, they are chosen as the leader to do it. Now there's a little bit of a thing like when these nodes are communicating between each other. You can say, okay, I'm sending information, someone else is sending information, then they can be hacked between those networks and all. So to avoid that, there is a process of encryption. And when I say encryption, so you encrypt the message, so you encrypt the information. So let's say I'm sending you a letter, then I put it inside a cover. So, and you are only allowed to open the cover and read it. So that's a way of I encrypted that in that cover so no one can read it, and the information passed to the system and it reached to you.
And that's a public and private keys, that
Yes.
whole
So yes.
mechanism
So
within
if you
an
compare that
encryption.
with the public and private key mechanism, you need a key for encryption and decryption. But here, I will break it down into two different pieces.
Okay.
I won't talk the technology today, but I'll give you a more relatable example here.
Okay.
So let's take an example of how you log into your Gmail account. You need an email ID and a password. So you can say that password is a private key for you, and your email ID, anyone can
public.
send email to
Yeah,
you. So
yeah.
your email address is
It's
a public key for you.
Yeah, yeah.
So it's
yeah.
open to everybody for communication,
Right.
but to accessing any information, you have the rights to use the password, the private key, to
Right.
read the information.
Yes, absolutely.
So that's how this
whole-
whole proof of work works.
Works.
Now here comes, I did the job. I need a reward now.
Yeah,
That's a social thing,
yeah.
isn't it? Like in society, if somebody does well, they are rewarded. So, and if I get more reward, I'll be more honest to these 100 people because
True.
I'm doing work. And it's similar with the organizations as well. Like you reward your employees,
Absolutely.
right? Based
Yeah,
on performance, based on some
Yeah.
some benchmarks. Similarly, here also reward mechanism works.
Okay.
And that reward mechanism makes these blockchain very, very, very powerful. The entire concept. So who is keeping this blockchain network active? These 100
Miners?
people? Yes,
Yeah,
these miners.
yeah,
So
yeah.
they need to be rewarded.
Yeah.
Rewarded with what? Okay, they did some
Bitcoin?
job. Yes.
Yeah.
So there is a currency for that to be paid. So yeah, like Bitcoin, Ether, we have, but we will talk more
Okay.
in a relatable sense now. But I won't go to the
Yeah.
task mechanism part now.
Okay.
So, yeah, sorry, I lost the flow now.
No,
Yeah,
it's-
so these miners need to be rewarded. So they are doing some task, they are getting rewarded. So when this particular thing works in a society or in a community or in a decentralized network, when I say in blockchain, so this makes this very, very, very powerful that people do not try to do illicit activity because they are heavily rewarded for keeping it secure.
Right, right.
So
right.
going forward, security is a question, and this is a secured security, I must say.
Okay.
It's a secured security because this is highly secured because of this reward mechanism, and that brings in the economics in this currency. So it's named as crypto economics,
Right.
and which basically talks about the incentives or the rewards given to the network participants,
Okay.
whatever their role is.
Okay.
I'm a staker, I'm a validator, I'm a miner, I'm a node operator,
Okay.
irrespective of the roles.
Okay.
But there is a process of rewarding your act.
Okay.
Act of doing what? Act of keeping the information right,
Okay.
act of keeping the information correct,
Yeah.
intact, secure, safe, private. So for these acts that you are doing in the network, that giving you reward.
Right, right.
So
And-
if you are evaluating a blockchain, so I would say, well, I'm not giving you trading advices, but let's say you are evaluating a blockchain,
Yeah.
then I would say look at the participants.
Okay.
The more the participants, more is the security of the network, and better is the reward mechanism.
Right.
The economics of rewarding the participants. That makes your network more secure, and they
Okay.
won't be ever, involved in any illicit activities because
Okay.
they are not they won't be rewarded that much, and they have to rather put more effort to hack the system.
Right,
So
right.
that cost more.
Okay.
So this is why this is important. Now I will give you an example of proof of stake. In relation to that, where you had all the workers and you found a best efficient worker to do it based on their work. Here it is based on the stake.
Okay.
So when I say stake, let's say there is a ecosystem where not everybody is allowed to participate, only the stakers are allowed to participate. When I say stakers, they are participating in the voting mechanism and the consensus mechanism. Let's say there are 20 stakers
Yeah.
who have, let's say I have 10 stakes.
Yeah.
Let's say 10, let's make it as a currency as X. So I have 10X, let's say you are also a participant and you have 20X. So you have a stake in the system. So let's say there are 5 of them or 20 of them, they have stake in the system who are participating in this voting process. They
Okay.
do the similar they do the similar encryption mechanism to pass the information within the network. There, the job was to do the hashing. Like the more you hash and the earlier you find the result, you are the winner to mine. But here, the more you stake, you have the higher chance to win, to be a validator for
Okay.
doing that process. So in proof
Right.
of work, if you compare the roles here, uh, there work is to find something. Here, to define something, you need to have stake. There, the winner is the miner. Here, there is a validator who is going to validate the transaction. There, the miner does the transaction, and here the validator does it.
So why would we still use proof of work? Why it's still there when the
Okay, it
interest was
depends on
more?
your use case. If you look at, let's compare the existing ones,
Okay.
Bitcoin and Ethereum, based on their consensus mechanism and
Okay.
the purpose. Basically, the purpose that's important.
Okay.
Bitcoin's idea is not to build any application on top of it. I won't go to ordinals and NFTs. Let's not go there now. Let's first understand. Here we are just passing value based on the UTXO model, where we are just calculating the unspent transaction output, and we are just exchanging the value, and that's how it looks like payment. Yeah, not looks like, it is basically payment where, like, if I have to give you 10 euros, and then it is somehow unspent in terms of cash, and the same is replicated in Bitcoin digitally. If I look at Ethereum blockchain, it is not only just that, it gives you a platform to build applications on
Yeah.
top of the network.
Right.
So that's their power.
Okay.
It is not just propagating a value, it is giving you an opportunity to build applications on top of it.
Okay.
And and just with the value, if a network is just exchanging values,
Right.
then it is not like not a problem with the congestion. Yes, there is a congestion of the network,
Yeah.
but if you are doing application and value like Ethereum is doing, this is why, like, to make it more highly scalable for applications and for payments,
Okay.
we have different layer 2 solutions. We will talk
Right.
about layer 2 solutions in future podcast, but
Right.
just to give an idea,
Yeah.
the purpose of Bitcoin is different from Ethereum.
Okay.
It's not just like based on the consensus mechanism.
Right.
Yes, the mechanism is different,
Yeah.
but the purpose is to have an application and a value. Here, just a value
Just a
exchange
value.
network.
Right. Interesting. That was a very good comparison between proof of work and proof of stake and Bitcoin and Ethereum, that we need both. We need both for different use cases.
Well,
We
there
need
are
both
so many
for
other differences which I
different-
did not
yeah.
cover. So to give a more idea, like, okay, it's not just those differences which I talked,
Proof
like
of work
the
and proof of stake.
stake.
Yeah.
They are different in other ways as well. I'll just give you a quick example of it.
Yeah.
Like when you are building applications on top of a blockchain network,
Right.
so there is a concept of tokenomics. I talked about crypto economics before.
Crypto
So
economics, token economics.
yes. So crypto economics is a way to keep the reward mechanism running within the ecosystem of those network participants. To keep the network highly available, because it needs to be available all the time, highly secured, and keep everything ready for scaling up, and the decentralization is working properly. So crypto economics is made for those participants. Tokenomics is for the users of that ecosystem, people who are using, let's say, Ethereum blockchain, where Ether is the
The currency
of
for
the
Ethereum.
network,
Yeah.
and you are building more apps on top of it.
Okay.
So this is why those applications needs tokens.
Okay.
So people who are using, they are not using crypto economics. Crypto economics for Ethereum blockchain is for those stakers, validators.
Right.
So there lies their crypto economics. The token economics for that is when they're building applications on top of it, and they're creating a token to interact with different applications.
All right.
And they make it interoperable and whatever.
Wow.
Like in terms of Ether, they keep on exchanging. So token economics work more on the application layer side.
Okay.
And crypto economics work more on the core layer of a blockchain network. So if you compare them, so crypto economics comes 1st in terms of, because it is part of the network. Tokenomics is part of the application. So application
Okay.
comes quite late. So
Right.
so if people like, sometimes I've heard this, like people little confuse those usage. I feel so. But that's my understanding of crypto economics and token economics.
Comparisons.
I would say something like this crypto economics is even better with Chainlink version 2 now. So they have
Okay.
launched Chainlink V2 paper, V2 white paper, and the crypto economics is more focused there. Yeah. And the ideal way of keeping a network secure is to reward more participants. More they are
More
rewarded,
rewarded?
they are more active to
More
keep the
trust
network.
and
Yes,
yeah,
to build
yeah.
the trust. So
Build the trust. Okay,
that's
that's
important.
fantastic.
All right.
And Baba, so what's so yes, so do you trade? Are you into crypto trading, into digital assets?
Uh, yes, I have done a bit in past, but I don't do that right now because I spend more time nowadays to understand them rather than just doing the trading.
Trading, yeah.
But
Okay.
yeah, so I would say the way I used to do was to understand more about uh, like more about the utility of the if it's a new token.
Utility,
Yeah,
definitely.
and what are the different like I will focus more or I'll talk more about
The
it
use
in the
case, probably.
tokenomics.
Oh, okay.
So
Okay.
you need to understand tokenomics properly if it's an
Okay.
application built on any of the blockchain.
Okay.
And if it's a new blockchain, then I more focus on the way they have implemented consensus mechanism
Okay.
and the participants and how scalabilities and why that network is built for. If you're looking at a application and if you're looking at a network, so there is a there are a few concepts in DeFi which you need to have a knowledge on it. Just not like if you are trading, okay, there are mathematics behind that, probably, which I don't understand, probably, that trading maths. But I try to understand the product, I try to
Okay.
understand the project. So that's where I got the knowledge and where
Yeah.
I did my master's and all this stuff.
Yeah.
So it's basically you look at how secure the network is. So I will take an example of Chainlink and I will explain that
Yeah.
why they are so secured. Because the participants, the way the crypto
Okay.
economics is designed to keep
Right.
the network highly secured, that makes them quite popular in the Oracle market.
Okay.
And
Right. Good to know. Yeah.
and if you look at the public permissionless blockchains like Ethereum, uh, their security lies on all the stakers because of the way proof of stake works and the number of stakers. That's their pillar because every network's pillar is consensus, which we talked, proof of work, proof of stake. There are many to it, like Byzantine fault tolerance
Yeah.
techniques. There are proof of delegated proof of stake. There is proof of elapsed time.
Wow.
There is proof of history, I think, and proof
Okay.
of capacity. Proof of capacity is a combination of different things. So, yeah, there are like several way of maintaining the consensus within the network. So, my point is, if you are evaluating a network, it's easy sometimes to evaluate. For your use case, or if you are working in any of the business, if you want to transform it and you want to decide a network. But if you are deciding on an application, on a token, it is even tough. You have to evaluate two things. One is the application, the goal of the what's that business is all about, and the tokenomics.
Yeah.
And you have to understand the network on top of what network it is being built, and you need to
Okay.
understand the crypto economics there. So there are like so many tasks to do if you are evaluating a token project, network project.
Right.
For your
Okay.
trading purpose or
Yeah.
whatever purpose. But yeah, these are basic tools, I would say.
Okay.
Don't just look at those numbers or
Okay.
charts. Try to understand the ideology behind this, the
Right.
philosophy, why they are doing it.
Philosophy
Philosophy.
of blockchain
Yes.
and philosophy of decentralization.
Yes.
Lovely. Yeah.
Thank you.
Perfect. Great. Thank you, Baba.
Thank you.
Namaste. Thank you.